Intro.
So I will be discussing the chapter 2.4, density, and the chapter 2.5, the pressure. So the first thing I will discuss is about density. The density, mass per unit of volume seawater, is governed by temperature and salinity, and to a lesser extent by hydrostatic pressure. As salinity increases, the density increases. As the temperature increases, the density decreases. Salinity and temperature are physically independent variables, but as we have seen, they are not randomly distributed in the ocean. Figure 2.14 ATS diagram showing the relationship between temperature, salinity, and density. For convenience, the density contours are shown as lines of equal values of sigma t, where equals to density minus 1 times 1000. Therefore, a density of 1.02781 grams per cubic meter has the equal of 27.81. So a density is a measurement of quantity, the amount or mass per unit of volume, the space being occupied. So if fresh water has a given density of 1 gram per cubic meter at 4 degrees Celsius, while seawater differs by having a 1.02 to 1.03 gram per cubic meter, which is the factor of temperature and the salinity that is visualized at the figure 2.14, explaining the relationship of temperature and salinity affecting the seawater density. We have here a 26.0 equals to the density minus 1 multiplied by 1000 in this equation. So the density of seawater is approximately 1.026 gram per cubic meter, which give us the complete equation of 1.026 gram per cubic meter minus 1 multiplied by 1000, giving us the line constant sigma of 26.0. Since the fresh water weighs around 1000 kilogram per cubic meter and the seawater weighs about 1.026 gram per cubic meter, it will be multiplied, giving us the typical seawater density of 1,026 kilogram per cubic meter. Temperature and salinity. Salinity also has the important effects of lowering the temperature at which the maximum density occurs and depressing the freezing point of the seawater. These changes are shown in figure 2.16. Note that the temperature of maximum density and the freezing point are the same at the salinity of about 25. Simply put, salinity affects density because of the compact salt substances that added to the mass of the seawater, while the temperature, on the other hand, affects density. The lower the temperature, the greater the density is. These two factors are interconnected but parallel to each other, affecting the density of a seawater. If the temperature rises, the substance dissolves, allowing the molecular content to spread and takes up more volume, affecting the positive relationship between density and the salinity. Also, the relationship of temperature and salinity on the density of a seawater, the higher the concentration of the dissolved salt resulting to the slower freezing point, a salt ion replaces many of the water molecules otherwise crash into the pure water surface, allowing it to freeze more slowly than the pure water. Advection, downwelling, and upwelling. The horizontal or vertical movement of water is referred to generally as advection. So advection is the horizontal or the side to the other side movement of the water. The sinking of water is called unwelling. It is when the surface water converge or come together. It pushes the surface water downwards and the movement of the surface is to the deeper depths. Upward movements of water are called upwelling. It is mostly or the movement of cold, deep, and often nutrient-rich water mixed with the surface layer. Pressure. Pressure is determined by the weight of the overlying water column per unit area at a particular depth. Hydrostatic pressure is another physical environment factor affecting life in the sea. Pressure can be measured in variety of units. Figure 2.18 expresses pressure in newtons per square meter. At 10-meter depth, the pressure is 10 newton meter. This is roughly equivalent to 1 atmospheric or 1 bar, which are the units conventionally used by biologists and scuba divers. So, pressure is defined as the force applied perpendicular to an object's surface per unit or over which that force is distributed. The pressure exerted by any fluid in any confined space is referred to as hydrostatic pressure. If there is fluid in container, there will be the same pressure on the container's wall. Eurybathic and STENOBATHIC. Certain animals, both benthic and pelagic species, do inhabit wide range depths in the sea, and these are considered to be eurybathic. So these are the animals or species that are capable of living on the bottom in both deep and shallow water or wide range of depths. Other species are intolerant of pressure change and remain restricted to narrow depth ranges. These are stenobatic species. Aquatic animals which only consider limited and vertical range or narrow depths area to survive. This is the end of my discussion on chapter 2.4 and 2.5, density and pressure. My name is Chrislyn K. Amasibuke.